so let's go ahead and go over the chapter 20 notes. Okay, so the notes that I provided for you guys have some vocabulary words here at the top. We will go over those. Some of them are just old vocabulary from the previous chapters, like p-value. You need to know what that is still. Statistically significant. You need to know what that is. Alpha level, significance level. So these are all old vocabulary words. You're just going to have to review them again. And then today's new vocabulary words we're going to talk about are a type 1 error, a type 2 error, and power. So first, let's go ahead and just start with an example here about being statistically significant or not. So let me remind you, statistically significant means that your p-value is less than the alpha level / significance level. So when your p-value is less than the significance / alpha level, then you reject the null hypothesis and your results are significant. So number one, go ahead and read it here and tell me, letter A, is this result statistically significant at 5% based on the p-value that is given? And then letter B, is the result statistically significant at 1% based on the p-value that is given? And you're supposed to explain, like, yes, it is because, or no, it's not because. So I'll give you a minute to read through those. And I think this was on the last test. So a medical researcher has tested a new treatment for poison ivy against the traditional ointment. With the p-value of 0.047, he concludes that the new treatment is more effective. So letter A, is the test statistically significant at 0.05? Yes or no? I guess you would say yes or no. I'm putting yes. So if you weren't sure, go ahead and write it down. Yes. In the explanation, you can just say yes because the p-value is less than the significance level. So this Greek letter A called alpha is called the significance level / the alpha level. And therefore, since 0.045 is less than 5, then yes, we have statistically significant results. Okay, now you do letter B. Is the test statistically significant at 1% or 0.01? Should have been just basic. No, because the p-value is greater than the significance level. Or in other words, 0.047 is bigger than the 0.01. So that was just like a little review of statistically significant. Now let's do some new stuff. Number 2. If you have any questions at any point, just let me know. Number 2. Okay, so this part we're going to need a calculator. Number 2. In June 2010, a random sample of 800 working men found that 9% had taken a second job to help pay the bills. Letter A. Let's go ahead and just use the calculator for letter A. Estimate the true percentage of men who are taking a second job by making a 95% confidence level or confidence interval. So let's go ahead and just use the calculator to do that. I'll remind you one more time how to do that. So first of all, let me make sure 800 times 0.09. It needs to be a whole number. Yeah, that's a whole number. Okay. So the way you do the interval again is menu, statistics, intervals, and remember it's called a 1 proportion Z interval because that's what we've been doing so far, 1 sample proportion. And then for the number of successes, you'll have to do what I just did, 800 times 0.09. And if it's a whole number, then it's good. So I just do 800 times 0.09. So those are the number of successes. 800 is your sample size. And 95% confidence level. So press OK. And just copy the lower and upper bound. So right here. So the interval would be from 0.07 to 0.11. We can just round to whatever, 2 or 3 decimal places is fine. So 0.07 to 0.11. Okay, so 7% to 11%, that's why I wrote it. You can write 0.07, comma, to 0.11, same thing. So that was just an old I guess, review, here is the actual new stuff for chapter 20. You need to be able to make a decision and conclusion based on the interval. Like on a hypothesis test, we know like I reject HO if the p-value is less than the significance. Here it's actually, we can reject or not reject HO based on an interval. And here's how you do it. So letter B, suppose you wish to conduct the hypothesis test to see if the true percentage of men taking a second job is greater than 6%. What does your interval indicate? So this interval is obviously all more than 6%. So most likely, like the true percentage of people, of men taking on a second job is probably more than 6%. But here's how you actually do it. So step one, what you want to do is you want to write down some hypotheses first. So for number 2, letter B, if you want to make a conclusion based on an interval, you start with writing some hypotheses. So here are my hypotheses. The null hypothesis, that's always harder. I always start with the alternative. The alternative hypothesis is what you suspect to be true, or like what you're trying to prove. So the question wants to know, is there evidence that the true proportion of men who are taking a second job is greater than 6%? So that's how I always start with the HA. So I'm going to put HA. P is greater than 6%. The null should just be the equal sign. Okay, so there's my hypothesis. Now you need to make your decision. So here's what you do. You look at your, I guess, your null hypothesis, and you look at your interval. Because the interval is all above the 6%, then we do have evidence that the true proportion of men who are taking a second job is more than 6%. We're like 95% sure. So here's actually how, I guess you can read this and write it however you want to with your own words. But here's what I said. Since the interval doesn't contain like the HO, the 6%, like equal to 6%, then we will reject the null hypothesis and conclude that the true proportion of men who are taking a second job is more than 6%, because the interval, which goes from 7 to 11, is clearly more than 6%. So in conclusion, when your null hypothesis is not contained in the interval, you reject the null hypothesis and conclude that HA is true. I should probably write that down. So one more time, like when your null hypothesis is not contained in the interval, then you reject the null hypothesis and conclude that HA is true. So in this case, since our null hypothesis of 6% is not contained in the interval, then you reject the null hypothesis and conclude that the alternative is true, or in other words, greater than 6%. So go ahead and write it down however you want to justify it. And then the last thing you need for these kind of questions is letter C. What is the level of significance? Okay, so here's the best way to explain it. I think it would help if you draw a picture. Okay, so let me draw a picture of like a normal curve, and I'm going to put 95% in the middle because that was the confidence level, 95%. So if there's 95% in the middle, that means that the tails each would have 2.5% on the top and then 2.5% on the bottom, because that's 5 divided by 2. So the level of significance in this case will just be the upper tail here, which is 2.5%. So here's how I would explain it. I would explain it definitely with the picture the first time. So draw a picture, draw 95% in the middle, and then I guess over here, draw 2.5%. And the way you can actually explain it is the level of significance is 2.5% because our interval was a 95% interval. And the HA that you were testing was a one-sided hypothesis. That just means like your HA was only the greater than side. So you were only looking at the upper tail. So greater than side, this was only looking at the upper tail. I think we'll do an example maybe today or later in your homework. When the HA is a not equal to, like not equal, That's called a two-sided hypothesis. So you would include the upper tail and the lower tail. So if this HA was not equal, then your significance here would be the whole 5%. So the 2.5 at the top plus the 2.5 at the bottom. But that's example 2. And now I'm going to pause the video. I'm going to give you about, 5 minutes to try number 3. Try just exactly the same way we just did it. Try number 3. Okay, so number 3. In 2001, a magazine reported the results of a study about the birth of twins. The study concluded that 12 sets of twins were born to 469 women. Use a 90% confidence interval to estimate the true proportion of twins among women. So we took that one sample. You should have just put it in your calculator and got that the true proportion of women who have twins is pretty small, somewhere between 1.4% and 3.8%. And remember, you can write it as a decimal if you prefer. So that was letter A. Now letter B says, suppose that the true proportion of twins among women is 3%. Does your interval provide evidence that the true proportion is any different? So for that, like I told you, I always start by writing some hypotheses to see if you're going to reject the null hypothesis or not reject the null hypothesis. So here we're assuming that the true proportion is equal to 3%. However, we want to know if the true proportion is any different. So I went ahead and put HA is not equal to 3%. So now, like I told you earlier, the way you reject or fail to reject the null depends on whether your null hypothesis, which in this case is 3%, is contained in the interval or not. So for this one, I would say since 3% is contained in this interval, then we do not reject the null hypothesis. And therefore we don't have enough evidence to conclude that the true proportion of twin births among women is any different than 3%. And that's how one way you can explain it. Another way you can say is, well, we're like 90% confident that the true proportion is somewhere between 1.4 and 3.8. So therefore 3% is there. We're about 90% sure that the 3% could be true. So in conclusion, one last time, when your null hypothesis is contained in the interval, then you do not reject the null hypothesis and you don't have evidence for HA. But when your null hypothesis is not contained in the interval, like the previous example, then you do reject the null hypothesis and you do conclude that HA is true, like the previous example. Finally, letter C, what is the level of significance? Here it is one more time, the picture. This was 90%, so I would draw 90% in the middle. And the HA here with a not equal to, that's called a two-sided hypothesis, which means you would have to include the upper tail and the lower tail. So for this example, my level of significance should be the whole 10% because there was 5% at the top plus 5% at the bottom. So I would put 10% because the level of significance was 90 and the HA was a two-sided hypothesis. And that's how you do half of chapter 20. Okay, so the last thing you'll need to know for chapter 20 is what is a type 1 error and a type 2 error. So you can read what it says here and look at the definitions at the front. But basically, here it goes. When you're doing a hypothesis test, there's either you either make a decision of I reject HO or I do not reject HO. So since there's two possible decisions to make, then that means that there's two possible errors or mistakes you could have made. And those are called type 1 errors and type 2 errors. So here's the definitions again from the front of your notes. A type 1 error is when you rejected a true HO. So you said I reject HO, but the HO turned out to be true. The probability of a type 1 error is known as alpha, the significance level. So make sure you memorize that. The second type of error possible is when you failed to reject an HO that was false. So like you said, I failed to reject HO, but actually HO turned out to be false. And that's called a type 2 error, also known as beta. So make sure you know the names, alpha and beta for type 1 and type 2. And here's a couple of other things that you need to know. Next, when you correctly reject a false HO, so you said I reject HO when it really was false, that's not a mistake. That's a good thing. And that's called power. So that's the third definition you need to know. Power is correctly rejecting a false null hypothesis. So that's a good thing. So those are the definitions that you must know. And then here's a bunch of facts. They're all written in your notes already. We should just read through them because you need to, I guess, memorize and understand these facts. A type 1 error is alpha, like I just told you. We use the Greek letter A. A type 2 error is beta. We use the Greek letter B. Power and beta are inversely related with this formula, so make sure you memorize this formula. Power is always equal to 1 minus the type 2 error. So memorize the formula. Next, alpha and power are directly related. So if one goes up, the other one goes up. Alpha and beta are inversely related. So if one goes up, the other one goes down. And then I just told you power and beta are also inversely related. When one goes up, the other one goes down. A few other facts. The researcher is free to determine the value of alpha. I'll tell you what that means. The experimenter cannot control beta since it depends on the alternative value. That's just like extra stuff. I think a good one to memorize for sure is the ideal situation is to have your type 1 error as small as possible, but to have power as close to 1, because power, you want it to be 100%. Next, you definitely need to know this. The best way to increase power without increasing a type 1 error, because remember, power and type 1 error are directly related. But one way to increase power without increasing type 1 is to increase the sample size. So memorize that fact. And then the last one is not as important, but the seriousness of the error just depends on the situation. So some of these facts you need to memorize. Okay, let's actually try an example about this. Number 4. It says, the Lay's, potato chip company decides to accept a truck of loaded potatoes based on the result obtained from a sample of potatoes from the truckload. So the company will sample some potatoes and will reject the whole truckload of potatoes if the potatoes that they sampled have any defects or are in bad shape. So we need to now find a type 1 error, type 2 error in context of the problem. So here's the first thing we'll need to do. We'll need to write some null and alternative hypotheses, like in words, like with context. So I'll tell you what they are now, and then I'll explain to you how to actually write them, because that's the hardest part. The way you write a null hypothesis, I guess a null hypothesis, you always assume like you're like in a magical land where everything's perfect. So for this scenario, the null hypothesis, I'm just going to read you what it says. It is the statement that we assume to be true. I guess like if we're being positive, the statement that we assume to be true. The statement of no effect, no difference. The alternative hypothesis, that's always the one you're trying to test. Like you're trying to test if the proportion has increased, or you're trying to test if it has decreased. Or in this case, like you're trying to test to see if the potatoes are bad. So back to letter A. The null hypothesis, we assume that the potatoes in the truck are good, like no bad potatoes or no defects. So write down, null hypothesis, potatoes are good, no defects. The alternative, however, is what we're trying to test. We're going to test to see if the potatoes are bad. So potatoes are bad, not good, or they do have defects, because that's what we're trying to test. That's why we took a sample to begin with. We want to see if the potatoes were bad. So that's the hardest part. We'll just have to practice writing the null and alternative. And you still have a long time before the quiz and before the test. So practice writing null and alternatives. Okay, now the next part is not that bad. Letter B, let's write a type 1 mistake. So remember that type 1, look at the definition. Type 1 is rejecting a true HO. So type 1 is when you reject the null hypothesis, even though it is actually true. So I don't know, give it a minute to think about how you would write down a type 1 mistake here. Type 1 would be saying you reject the potatoes, even though they were actually good. So I'll help you with this first one, and then you'll try the next example. So type 1 mistake. it would be rejecting the potatoes even though the potatoes were actually good. Or in other words, exactly what I wrote. Rejecting a truckload of good potatoes. So one more time, a type 1 error is rejecting a true HO. So in a type 1 error, you would reject the potatoes even though the null hypothesis was actually true. So you would reject the potatoes even though the potatoes were actually good. This first time is going to be confusing, but the more you practice, the better it'll be. So let's try it the same way with the type 2. A type 2 error, I'll read you the definition one more time. Type 2, it is failing to reject a false HO. So in a type 2, HO is false, but you failed to reject it. So in this scenario, I guess the potatoes were bad, but you did not recognize that. Or in other words, you accepted a truckload of bad potatoes. And your words don't have to be exactly like mine. For type 2, you could have said, we failed to reject the bad potatoes because we failed to reject a false HO. Or in other words, we accepted bad potatoes. So you're going to have to just practice writing type 1 and type 2 errors. So most of your quiz in the AP Classroom, it's all multiple choice. Most of the quiz is just interpreting type 1 and type 2 errors in context of the scenario. So make sure you practice that before you take the AP Classroom quiz on Thursday. So finally, power. Power, let me read you the definition one last time. Power is a good thing. Power is correctly rejecting a false HO. So power is when you correctly reject HO when HO was false. So HO is false means that the potatoes are actually bad. And in power, you rejected the bad potatoes. So I put the probability of you don't have to really have the words, the probability. You can just say rejecting bad potatoes. And that's I have a couple more D and E. Or actually letter E. So that we need to practice. The last thing I need to show you is letter E and F, and then you'll try number 5 by yourself. Copy that down if you want to have it down. If not, you can watch the video that I'm making. Okay, so letter E. Based on all the facts that I gave you about type 1 and type 2 errors, letter E says, if the test is tested at 1% significance instead of the 5%, how will it affect power? So in other words, if we decrease alpha from 5% down to 1%, what is that going to do to power? And remember, power and alpha are directly related. So if I decrease from 5% to 1%, that means that I'm going to decrease my power. Let me pause my recording. Okay, so letter F. The company hoped to make their decision by testing 500 potatoes. So the sample size was going to be 500 potatoes. But because of time and budget constraints, they may be forced to cut back to only 200 potatoes. So you have decreased the sample size. How would this affect the power of the test? So again, if you go back to the facts that I gave you, sample size and power are directly related. So if you cut down the sample size from 500 to 200, you're going to cut down the power as well. So those are some facts you've got to know. And now that's the end of chapter 20, which is what you'll need for your quiz. On Thursday, we'll just continue doing reviewing chapter 20 and doing one more thing. But I mean, this is it. I'm going to just let you do number 5 by yourself, and then I can show you the answers.